Hi, my name is Muhammad Afiq Aziz bin Musledi and my matrix number is 2021-2096-76.
Assalamualaikum and hi, my name is Nur Humaira binti Rosli. My ID matrix is 20218178004.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syabir Hakim bin Miskam and my matrix number is 20218152228.
Hi, Assalamualaikum. My name is Amirul Hakim bin Laman Hakim and my student ID is 2021-625-208.
The content of this topic including definition of differentiation, type of methods, related rates, and we are going to do some example question. Today we are going to learn about application of differentiation. First of all, what is differentiation? Differentiation is a process of finding the derivative or rate of change of a function, and it can be solved by using three types of methods. The first one is product rule, second is quotient rule, and next is chain rule. A related rates problem is a practical problem that involves a functional relationship y equal to fx, which both x and y are then self-function of another variable such as time t. So the learning objective for today is we are going to understand the application of a derivative. Now we are going to do some example question. First question. The diagram shows a conical flask filled with water with high hcm and radius of the circular surface as rcm. The height of the cone is 10 cm and the base diameter is 12 cm. The cone is filled with water at a constant rate of 0.2 cm3 per second. Find A. The rate of change for the height of the water level, and B. The rate of change for the surface area of the water at the instant h equal to 1/6 pi. Given dV over dt equal to 0.2 cm3 per second, where V represents the volume and T represents the time.
So for the first question, which is question A, we need to find the rate of change for the head of the water level. So how we can solve the problem? So the strategy is we need to use the chain rule. So in the question, we has been given the value of dV over dt, which is 0.2 cm3 per second, where V represent the volume and the T is represent the time. So now the formula for volume of cone is 1/3 pi times r squared times h. So now we have a new problem, which is we don't know what is the value of r. So how we can find it? So in the slide that has been prepared, we can see that there is a half cross section of triangle, which is triangle ABC and triangle ADE. So we can see that it is a similar triangle because it is enlargement on the same point, which is point A. Because point A, from point A, it will go to point D and it will go to point B. And from point A, it will go to point E and it will go to point C. So we just use the enlargement equation, which is R divided by C and equal to H divided by 10. And now we need to single the R and we produce and R, the value of R is 3H over 5. So now we have the value of R. So now we just need to substitute the value of R into the formula of volume of cone, which is it will make an equation V equal to 1/3 times pi in bracket 3/5 times by h, close bracket, power of 2, and times by h. And when we solve it, we will have the value equal to 3 over 25 times by pi times by h power of 3. And now we have the value of v. So now we need to find the value of dv over dh. So how we can find it? We just need to make a differentiation. We need to differentiate it. So when after we differentiate it, we will get the value is 9 over 25 times by 2 pi times by h power of 2. So now we're going to use the chain rule, because we has two value, which is value of dv over dh and the value of dv over dt. So now we just need to substitute it in the equation, which is the equation is dh over dt equal to dh over dv times by dv over dt. So now we have a new problem. What is the problem? The problem is we don't know what is the value of dh over dv, because before we just get the value of dv over dh. So now we just need, so how we can find the value of dv over dh? We just need to over it with 1, and it will make the 25 on the top and the 9 pi h power of 2 on the bottom. So we can have the equation that the value is equal to 25 over 9 pi h power of 2, which is that is the value of dh over dt times by the value of dv over dt, which is 0.2, and after we solve it, we can get the value which is 5 over 9 pi h power of 2. So now we have the value of dh over dt, but in the question has given us the instant value of h, which is 1 over 6 pi. So we need to substitute the value h. We need to substitute the value of h. So after we substitute, we can get that 5 over 9 pi in the bracket 1 over 6 pi close bracket power of 2. Then after we solve it, we will have the value of dh over dt, which is 20 pi cm per second. So that's how we solve the problem of question A.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for the question B, the rate of change for the surface area of the water at the instance h equal to 1 over 6 pi. We provided dv over dt equal to 0.2 cm cube per second. The question need us to find rate of change for the surface area, which is dA over dt, that equal to dv over dt times dA over dv by using cross multiplication. But we don't have dA over dv, so we need to find it first by using dA over dr times dr over dv by using cross multiplication. Firstly, by using the formula of area and volume of the cone, we need to differentiate it to make it become dA over dr and dr over dv. For area of the cone, A equal to pi r squared. When we differentiate it, we will get dA over dr equal to 2 pi r. And for the volume of the cone, the formula is 1 over 3 pi r squared h, but we can substitute h with 5r over 3 based on the working in question A, and we will get 5 over 9 pi r cube. After that, we need to differentiate it, and it will become 5 over 3 pi r squared. But the answer is for dv over dr. We need to find dr over dv, so we need to inverse the equation, and we will get 3 over 5 pi r squared. Alright, we already get dA over dr and dr over dv. So we need to multiply it to make it become dA over dv. The working is dA over dv equal to 2 pi r times 3 over 5 pi r squared by using cross multiplication, and we will get 6 over 5r. After that, we need to find dA over dt by multiply dv over dt with dA over dv. dA over dt equal to 0.2 times 6 over 5r, and we will get 0.24 over r. We know that r equal to 3h over 5, so we can substitute it, and we will get the answer for the rate of change for the surface area of the water, which is 2.4 pi cm squared per second.
In conclusion, related rate and problem involving rate takes advantage of quantity that are related to each other. Related rate help us to determine how fast or slow a certain quantity is changing using rate of change of second quantity. Now we are able to understand the idea of differentiation using chain rule or implicit differentiation. So that's all from us. Thank you for watching.